Section 7.4 Geometrically defined vectors and applications. Basic terminology. Scalar. The magnitude of a quantity. It can be represented by a real number. So look at this vector OP. Scalar, talking about the magnitude of this line here. A vector in the plane is a directed line segment. So vector, they do have the direction. Consider vector OP. You could see the letter OP, we bold it, it represents the vector. Or you could use the arrow on the top, represent this as a vector. On the exam, I will expect you guys either you bold the letter like this way or you put the arrow on the top to represent the vector. O is called the initial point. So it's starting from this point here. P is called the terminal point. Okay, so OP talking about they do have the direction starting from O and going to P here. Magnitude, length of a vector expressed as absolute value of OP. You see, you're gonna bold the letter or you're gonna put the arrow on the top. So magnitude of OP here. So every time when you guys see the notation, the absolute value of the OP, you know that we are looking for the length of the vector. Two vectors are equal if and only if they have the same magnitude and same direction. Vectors OP and PO have the same magnitude. They do have the same distance, but opposite direction, so they are going to different direction here. Okay, magnitude, the distance are equal, but the direction is going to be opposite. So look at this example here. So you can see vector A and vector B, they do have the same magnitude and same direction, so they are equal to each other. Same idea with C and D. But vector A and vector E, they're going on different direction. They do have the same magnitude, but they have a different direction. And then vector A and vector F, they are going to the same direction, but they have a different magnitude. So they are not equal to each other. Sum of two vectors. The sum of two vectors is also a vector. There are two ways to find the sum of two vectors A and B geometrically. Look at this picture. We do have the vector A and then vector B. We want to find the resultant vector, which is going to be A plus B here. So this is the first method, finding the resultant vector. You're going to paste the initial point of the vector B at the terminal point of the vector A. Okay, you can see initial point of the P. You can see the initial point of vector B. You're gonna put it at the terminal point of the vector A. So when they add it up together, that will be A plus B. So this is gonna be the first method. Second one, use the parallelogram rule. Paste the vectors A and B so that their initial points coincide. Okay, they do have the same initial point, A and B. Then we're gonna complete a parallelogram that has A and B has two sides. Okay, we're gonna copy the A here, copy the B here. It makes like the parallelogram. And then the diagonal of the parallelogram with the same initial point has A and B will be the sum of A plus B. So all these three lines, they do have the same initial point. And this line will be the resultant vector A plus B. So this is going to be the second method. And again, the sum A plus B will be called the resultant. Sum of the vector V and its opposite negative V has a magnitude 0 and is called the zero vector. So think about it. If this is the vector V, I'm going on this direction. And let's say this is going to be 10 centimeters. Okay, but if I have the same vector but going on different direction is also 10 centimeters. So when you add it up, that will become 0. And we call this is the 0 vector, the v plus negative v. To subtract vector b from vector a, we want to find the vector sum a plus negative b. So look at this picture. We do have a vector a and vector b. And looks like they want to use the parallelogram rule. Okay, so we have to change the direction of the vector b. We're gonna make it like negative b. Okay, so we're gonna create the parallelogram. And you know the resultant is gonna be going like this way, a plus negative b. Or you could use the first method. You're gonna place the initial point of the vector b at the terminal point of the vector a. So what can we do? We're gonna change this direction, become negative b, and then we're gonna paste the negative b here. So the initial point of the vector b will be at the terminal point of the vector a, and this is gonna be the resultant. Okay, so look at here, that will be the method 1. Scalar product of a vector. The scalar product of a real number k and a vector u is the vector k times u. Okay, k will be the magnitude. K times the magnitude of u here. So you can see this is my vector u. Let's say my k is equal to 2. So 2 times u, that means we do have the same direction, but we're going to be 2 times the magnitude of u here. And you can see the negative 2u, this is means you're going to go to the opposite direction, negative 2. Okay? Properties of parallelogram. A parallelogram is a quadrilateral whose opposite sides are parallel. So you can see these two sides, RS will be parallel to VT, and VR will be parallel to the TS. Second, opposite sides and opposite angle of a parallelogram are equal. So opposite sides, talking about RS, will be equal to VT, and VR will be equal to ST. And opposite angle, you could think about it, angle R will be equal to the angle T. And angle V will be equal to angle S. And adjacent angles of a parallelogram are supplementary. So adjacent angles, talking about these two, angle R plus angle V, that will be equal to 180. Or adjacent angle, angle R plus angle S will be also equal to 180. Same idea, angle S plus angle T is going to be equal to 180. Okay, adjacent angles. Number 3, the diagonals of a parallelogram bisect each other, but do not necessarily bisect the angles of a parallelogram. So look at this picture. The diagonals of the parallelogram, we intersect and we got the point M here. Then RM will be concurrent to MT. Okay? Congruent. This notation means congruent. They're exactly the same with each other. And also, VM will be concurrent to MS. They will be equal to each other. So this is the properties of parallelogram. Example 1. Two forces of 15 and 22 newtons act on a point in the plane. A newton is a unit of force that equals 0.225 pounds. If the angle between the force is 100 degrees, okay, we do have a 15 Newton, 22 Newton. Angle between these two forces will be 100 degrees. Find the magnitude of the resultant vector. So we're going to have the resultant vector here, and we label it as V. Okay. So we're gonna look at this triangle. We know this is PS is 22, SR is 15. And we want to find out the magnitude of the resulting vector V here. So first, we want to find out what is the angle S and the angle Q here. Okay, so we're gonna apply one of the properties. Adjacent angles of the parallelogram are supplementary. Okay, means angle P plus angle S, that will be equal to 180. Alright, or angle P plus angle Q, that's also equal to 180. So meaning that angle S and angle Q, that will be equal to 80 degrees. Now we're gonna use the law of the cosine. Okay, we know these two lengths, we know the angle in between. Now we want to find the magnitude of the V here. So when you guys try plug in to the law of cosine and use your calculator, okay, plug it in. Use your calculator. You should get 594. Take the square root. You're gonna get the magnitude of the resulting vector will be equal to 24. Okay, make sure you state the unit for your final answer. The equivalence. Sometimes it is necessary to find a vector that will counterbalance a resultant. And the opposite vector is called the equivalent. The equivalent of vector u is the vector negative u. Okay, opposite direction, but they do have the same magnitude. Look at this example. Find the magnitude of the equivalent force of 48 newtons and 16 newtons acting on a point A. Okay, acting on a point A. So 48 newtons, 60 newtons. If the angle between the force is 50, so in between these two forces is 50 degrees, then find the angle between the equivalent and the 48 Newton force. So this is V, right? This is the resultant force, V, and then the magnitude of the equivalent force will be opposite, so it's a negative V. And we want to find the angle in between negative V and then the 48 Newton, which is going to be the alpha. Okay, we are looking for this angle. The magnitude of negative V is the same as the magnitude of V. Okay, so we know this is a 50 degree and this is a parallelogram. So adjacent angle will be 130. Okay, supplementary, right? 130 plus 50, that will be equal to 180. And then we could move the vector. This is 60, so this is 60 also. This is a 48, this is also 48. Now we're gonna apply law of the cosine. Okay, we know these two lines, we know angle in between, and we want to find out the V here. Okay, plug it in. Try and then use your calculator. Okay, check your work. You should get V equal to about 98 newtons. Okay, we found out 98 newtons in here. And we are not done yet, right? We want to find out the angle alpha. So the required angle alpha can be found by subtracting angle CAB from 180 degrees. use the law of the sine to find the CAB. Okay, so we need to figure out what is this angle. And then we're going to use the law of the sine. Okay, so angle CAB, which is this angle, and then opposite side will be 60. And then we know 130 sine 130 over the V, which is going to be 98. We just found it from the previous slide. Okay, cos multiplication, use your calculator, you're going to get this guy. Okay, inverse of the sine CAB, you should get the angle. It's going to be 28 degrees. And we are not done yet. We only find out the CAB. We only find this angle. We want to find the alpha. So we're going to use 180 minus 28. That will be your alpha. Okay, example 3. Find the force required to keep a 50-pound wagon from sliding down a ramp inclined at 20 degrees to the horizontal. Assume there's no friction. So we do have the picture here. Let's do it together. So first we know this wagon is 50 pounds. So we're gonna draw the force here. Okay? And 50 pounds of this wagon. And then we have the point B and then the point A here. So the vector BA represents the force of gravity. And then we intersect this point, so we got the D here. And then we know that this is a 20 degree to the horizontal, talking about the angle BED will be 20 degree. And this creates a white triangle. This is going to be a 90 degree here. Okay, and then we are looking for the force F to keep this wagon from sliding down. So we're going to be going up. The BF represent the force that would pull the weight up the ramp. Okay, and then we have one more force, the BC. BC represents the force with which the weight push against the ramp. So you guys remember the physics, the action and reaction. Okay, and this is create another 90 degree here. Okay, the F and then the C create the 90 degree. Now, I could move the force, the BF, from here to here to create a triangle. Okay, and that will be a white triangle again. And since the vector BF and then the AC are equal, so the magnitude of AC gives the magnitude of the required force. So if you can find the magnitude of AC, that will be the force required to keep the wagon from sliding down. Okay, now consider this triangle. Okay, EBD, this triangle. How can we find the angle B here? Okay, we could do 180 minus 20 minus 90, which is gonna be 70 degree. Okay, what is that? 70 degree for this point. And then we know the BF and then the AC, they are parallel to each other. Okay, so remember the alternate interior angle. So the angle B will be equal to the angle A here, which is going to be 70 degree. And again, A, B, C, this angle, that will be 20 degree as well. Okay, right? We do have all the information. Now, we want to find the force AC here. Okay, only consider the triangle ABC. Okay, only look at this triangle. We want to find the AC. So we could use the side, right? Side tan t equal to opposite over hypotenuse. Okay, hypotenuse, which is going to be 50 Newton. Times 50 for both sides. Use your calculator. You should get magnitude of the AC will be about 17. So answer the question. A force of approximately 17 pounds will keep the wagon from sliding down the ramp. Okay, example 4. Finding an inclined angle. So, pretty similar to the example 3. I want you guys try to do it by yourself.
Lawn. Mower.
Okay, let's do it together. A force of 16 pounds is required to hold a 14-pound lawnmower on an incline. What angle does the incline make the horizontal? So we are looking for the incline angle, which is like here. So now let's try to draw all the information to this picture. So we do have a force of 16 pounds is required. Okay, so going up, the BE here, that will be the force, which is 16 newtons. So first, a force of 16 pounds is required to hold the lawnmower. So we're gonna have a BE here, which is gonna be the 16 pounds. Okay, the vector BE will represent the force required to hold the mower on the incline. And then we do have the BA, the weight of the lawnmower. Okay, magnitude of the vector BA will represent the weight of the mower. And then they create a 90 degrees here. And also, we have the vector BC. This is represent the force which the weight push against the ramp. Okay, action and reaction. We do have the BC here. And then we could move the BE to the AC here. Okay, I could move the vector as long as they do have the same vector and then the same magnitude. And this is also the 16 pound. Okay, now we create a white triangle here. And then vector AC equals to the vector BE. We know that, right? Because we move it from BE to the AC here. And this is also the 90 degree. Good. Okay, now we want to figure out the incline angle, which is going to be your theta. And then from previous example, we know this theta will be equal to angle ABC. Okay, this is the theta as well. Now we're gonna do sine theta over opposite. So now we're gonna do sine theta equal to opposite over hypotenuse. Use a calculator. You're gonna get B equal to 23.6 degree. Okay, angle B will be the same angle as the data here. So answer the question. The heel makes an angle of about 23.6 degree with the horizontal. Example 5. A ship leaves port on a bearing of 28 degree and travel 8.20 mile. So talking about a ship here, okay, starting from here, go bearing from the loft to here is 28 degree and travel 8.20 mile. The ship then turns due east, okay, go to the east and travel 4.30 mile. How far is the ship from port and what is bearing from port? Okay, so vector PA and AE represent the ship's path, and we are seeking the magnitude and bearing of PE. Okay, so we are looking for the magnitude of PE and also the bearing of PE. So first, P and A, this is a right triangle. Okay, you know this is a 90 degree. So we should be able to figure out what is the PAN. Okay, I want to find out this angle. So which is gonna be 62 degree here. Okay, and then we're gonna find out the PAE. Okay, PAE here, this angle, you have to find it by yourself. Okay, you could look at the question, they never given PAE is equal to 180. You could look at the question, they never given the angle PAE equal to 118 degree. Okay, so what they do, they gotta find out the PAN, okay, this angle, and then subtract from 180 to figure out 118 degree here. Okay, and then now we know this magnitude, and then we know the angle in between. So we could apply the law of cosine to figure out the magnitude of the PE here. Okay, plug it in. Try to use your calculator. So you should get 10.9. Okay, we find out the magnitude here. So answer the question, the ship is about 10.9 miles from the port. So we find out the magnitude of the PE. Now we want to find out the bearing from the port. So we need to know what is the angle here. Angle APE, okay, this angle. So we're gonna use the law of sine, okay? Angle APE, this angle over 4.3 equal to sine 118 over the PE, which is going to be 10.9 from the previous slide. Cross multiplication, use your calculator. You should get 20.4 degree. Okay, so this one is going to be 20.4. And then we're going to add up the 28 degree to find the bearing. So which is 48.4 degree. Okay, air speed and ground speed. So air speed of the plane is its speed relative to the air. Okay, this is the air speed. And then we have the ground speed. Ground speed of a plane is its speed relative to the ground. And then the ground speed of the plane represented by the vector sum of the airspeed and the wind speed vector. So this is talking about we do have the bearing and the airspeed going like this way, right? But at the same time, we do have the wind, okay? And then the wind make the bearing and the airspeed go a little bit like this way, okay? So that will be this line, okay? This is the bearing and the airspeed, and this is the wind direction, okay? Direction, the wind direction going on this way, and make it like the resultant, the blue one here, okay? Example 6, applying vectors to a navigation problem. So this one, let's do it together. An airplane that is following a bearing of 239 degrees at an airspeed of 425 miles per hour encounters a wind blowing at 36 miles per hour from a direction of 115. So let's try to sketch the first one here. Airplane that is following a bearing of 239 degrees. So we have the north, east, south, and then the west here. So the airplane that is following a bearing of 239 degrees. So starting from here, about like here. And then we have the straight line here. So this is a 209 degree, okay? And then the airspeed is about 425 miles per hour. So 425 miles per hour. And then we're gonna say this is gonna be point A, okay, going like this way. And then there is wind blowing at 36 miles per hour from a direction of 115 degree. So we're gonna draw another compass here, and we call this as a N1, E1, S1, and then the W1 here. And then we have 115 degree. 115 degrees is gonna be more than 90. So somewhere like here, 115 degree. So we do have the wind blowing. Okay, let me extend it here. Okay, and we call this is gonna be the point B. Find the resulting bearing and ground speed of the plane. So we do have the resulting force going from here. Okay, and then we call just the point C here. Okay, one more information. This is 36 miles per hour. Let me stay here. Okay, since this is the A, so we're gonna put A equal to 36 miles per hour. And this is a C, so this is C equal to 425 miles per hour. And then we are looking for the B here. Okay, this is gonna be the resulting vector. Okay, so we want to find out the angle B here, this point, okay? I label it. I want to find the angle ABC. Okay, so look at here. Vector C, which is here, represent the airspeed and the bearing of the plane, right? And then vector A, which is gonna be here, represent the speed and the direction of the wind. Good. And then angle ABC, ABC will be equal to angle ABN. Okay, we do have a two separate angle, AB N1 and N1 BC. So this is talking about we need to find out this angle, and also we need to find out this angle. When you add up together, that will be angle ABC. Okay, So in order to find this angle, angle AB and 1, we're going to think about this angle, okay, which is going to be your angle. Use this one. We need to find out what's an angle SAB. And we know the total angle here, that's a 239. And then from the north to the south, that's a 180. So angle SAB, that will be equal to 239 minus 180. Use your calculator, you're gonna get 59 degree. 59 degree. Okay, write it down, 59 degree. Okay, and then this one, remember the alternate interior angle. If this is a 59, this angle is also 59 degree. Okay, the reason is alternate interior angle. They are equal to each other. Now, we want to find the N1BC, the OH angle in here. So you could think about it. This is the straight line. It's supposed to be 180. And then from N1 to this part, this is a 115 degree. So we should be able to find the N1BC, the orange angle. Okay? The angle N1BC, which is gonna be 180 minus 115. You should get 65 degree. Okay, so 65 degree here. So now you could add it up these two angles. 65 plus 59, that will be angle ABC, which is going to be 124 degree. Okay, so you should have the picture like this. Angle ABC, this one will be equal to 124 degree. So we know the magnitude of BC, the magnitude of AB, and then we know the angle in between. So you could use the law of cosine to find the magnitude of B. Try, plug it in. Use your calculator. Okay, you should get 446 miles per hour. And then we are not done yet. We only find the magnitude of the resulting force here. We also need to find the bearing. The bearing starting from the north until here. And then we want to find the alpha. Okay? So now we're going to use the law of sine. Okay? Sine alpha over 36 equal to sine 124 over 446. Cos multiplication. Use your calculator. You're gonna see alpha is about equal to 4 degree. So the bearing of the resulting force will be 239 plus 4 degree, which is gonna be 243 degree. That's it.